is Nat with We Learn to Share, and this is Formulas and Bonds in Pre-IB Chemistry. So again, this is a brief course overview. Today we are on the second lesson, Formulas and Bonds, and I will be going over how bonds work and how to name formulas. So first off, there are two main types of bonds, ionic and covalent bonds. With ionic bonds, two oppositely charged atoms transfer electrons to create a compound. This happens with metals or transition metals and nonmetals. This bond type is stronger and it forms a lattice structure. With covalent bonds, two nonmetals or a metalloid and a nonmetal share electrons. These outer shells overlap to share the valence electrons. And this is how you name and write the formulas for each. So first off, we'll be going over naming formulas. These are names such as sodium chloride and carbon monoxide. So I'm sure all of you have heard of sodium chloride before. That is salt, pure regular table salt. And that is an example of an ionic compound, since sodium is a metal and chlorine is a nonmetal. So to name an ionic compound, first you want to find the charge of the metal. And you want to see if it's a transition metal, just write down the charge really small as a superscript for now. So if you're writing charges, you write them as 2 plus and never plus 2 or whatever the charge is. Whoops, sorry. And then you put the name of the metal first. As you can see here with this example, sodium goes first. And then if it is a transition metal, you put the charge in brackets as Roman numerals. And then the nonmetal goes at the end with, as you can see with this example, chlorine. The ending is changed to ide, I-D-E. So that makes sodium chloride. And so with covalent bonds, you put the name of the element furthest to the left of the periodic table first. If they are in the same group, the furthest one down is put first. So with this example, that would be carbon. And then for the second element, you add ide to the end of it, carbon monoxide. And as you can see here, there's a little prefix before the oxide, mono, which means 1. You add prefixes in correspondence with the number of atoms. You've all heard of carbon dioxide. That just means 1 carbon atom with 2 oxygen atoms. And there's carbonate, which is a polyatomic ion, which we will be getting into later. Now let's move on to writing formulas. This is a little bit more complicated since you will have to learn how to balance equations, but that will be taught in a later lesson. For now, for ionic bonds, you find the element on the periodic table and you write them down. So sodium is Na and chlorine is Cl. So you write them down. And then you find the charges of said elements and then you simplify them to a ratio. For sodium, the charge is +1. For chlorine, the charge is -1. And these two charges are at a 1-to-1 ratio and they already cancel out, so you just write it as NaCl. Once this ratio is established, you write them down as subscripts if there are any. And for covalent bonds, you find the element on the periodic table, write them down in order, like if you're converting carbon monoxide to CO, carbon comes first, you write C down, and then oxygen comes next, you write O down. And then you convert the prefixes to their respective numbers and write them as subscripts. Now, since it's carbon monoxide and there's 1 oxygen atom, you do not need to write a subscript. And here are the prefixes. These are derived from Greek. So mono is 1, di is 2, tri is 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. And now let's move on to electronegativity. So with electronegativity, that simply refers to the relative ability of an atom to attract shared electrons to itself. And what does this mean for ionic and covalent bonds? So ionic compounds are one element that has a high electronegativity and one element that has a low negativity, and they are attracted to each other, and that forms an ionic compound. For covalent compounds, they have similar electronegativity, therefore they share electrons. Next, we are going to focus on the models of each bond. For ionic bonding, the model is a Bohr model, which focuses on valence electrons. This is used to show ions and the transition of valence electrons. You can find both of these models in the notes attached at the end of the slides. For covalent bonds, you don't necessarily draw a model, but you do write them down as a Lewis structure. Lines are used to show which electrons are shared and which aren't. This is an example of a Bohr model. Now let's move on. I'm sure you heard me say earlier, I mentioned polyatomic ions such as carbonate. These are present in ionic compounds, and they are charged ions of 2 or more nonmetals. They are treated as elements, and when writing them down with subscripts, you write them in parentheses. So an example is ammonium carbonate. Ammonium is a polyatomic ion comprised of nitrogen and 4 hydrogen atoms. With this, you would write it down as parentheses NH subscript 4, close parentheses, 2, and then carbonate, which is CO subscript 3. You can find these in my notes. And that is the balanced formula for ammonium carbonate. Another thing I wanted to talk about was dots versus lines in Lewis structures. Again, these are in my notes. You can go right through them. Within a Lewis structure, a line represents 2 electrons and a dot represents 1 electron. So that is just a distinction that I want you to make. Here are extra resources. Again, the online periodic table, my notes, Quizlet set on naming compounds so that you can practice. More on polyatomic ions. And thank you so much for watching. If you have any questions, please comment them. Please like and subscribe. Thank you so much.